Hey guys, today we are looking into some data types, especially non-floating point numbers, so integer values only. Here we have the S-byte, the short, the char, or char for character if you prefer, our well-known integer, long, int182, and the big integer. In every example, we print the maximum value of every data type except for the big integer where there is no such constant. We will look into this one in a bit. If we run it, you can see the S-byte is 127. So you might not know S-byte. There is the byte variation, which goes from 0 to 255, I believe. And the S-byte is with a sign, so that is it can go below 0, just like integer, for example. You can see I ordered the data types by size, so the number gets bigger every time. Personally, I haven't used the int 182. Have you? Let me know in the comments. And besides the big integer, there is a max value constant everywhere. So in the big integer version, there is none. As you can see here, there is a max function, but no max value constant. So is there a way to get to some max value, maybe manually? Let's see. In this example, we create our big integer ourselves. And there are various overloads, as you can see here. And one of them is one with a byte array. So what I tried to do here is create an endless stream of ones with enumerable repeat. And in a loop, I increase the size by 8. So I start with 8, and on every iteration, I increase it by 8 until 64. And then I create a new big integer with this amount of 1 bytes and print it out. And just for fun, I did the same with 1024. So let's see what this program prints out. All right. You can see the int 182 is pretty big, as we've seen in the last example. And with 16 bytes, the number is almost as big as the int 128. As you can see here and here and here, the number is getting pretty large. And in the last example here, we have the one with 1024 bytes. And as you can see, this number is extremely, extremely huge. Just so you can get a feel of how big these numbers actually are, I have made a list of numbers. And there is a great site here where you can look up some interesting numbers. And just to point out a few, we have 10 to the power of 12. That represents the number of seconds in 32,000 years. 10 to the power of 18 is the number of atoms in a grain of salt. And with 10 to the power of 33, we have half the weight of the sun in grams. If we go up to 66, we have the number of atoms in our whole galaxy. So, okay, that's pretty big. But what about the big integer? According to this Stack Overflow post here, the maximum value is 2 to the power of 68. What's that? Is 2 to the power of 68 and something billion. This is incomprehensibly large. I mean, I can't imagine a use case where one would actually need to use such big numbers. But maybe you have a use case. Let me know, maybe in cryptography or scientific research. But what I'm interested in is how can the big integer actually get to these huge numbers? How does it store it internally? What I found to be interesting is the constructor with the long overload. So if we have a big integer with a long, and we look into it, then we can see at first glance that there is some sign and bits, and there are some various optimization made here depending on whether the number is small or not. We won't go over all the details here, but if we scroll down a bit, you can see the interesting part here. If it's bigger than uint max value, it's going into this else case, and then it creates some sort of an array, an unsigned integer array, where it stores the first half of the long and the second half independently of each other. So this is an array. If you look here, internal read-only uint bits. So if we go back to the example here with the bytes and look into here, it's very much code. It's pretty complicated stuff. But somewhere we see array copy into bits, and this val here is, where is it? Is a local variable with dword count, and this one here is dependent on the length of the span that gets into here. So the span points to our array. So this thing can get as big as the array can get, pretty much. That's the reason why the number is so huge. So you are probably only limited by the amount of memory you have in your system. Maybe we can look into the addition of two big integers. Let's see. Okay, let's see. When we add two big integers together, it looks, for the bits variable, you might not have seen this, but that was an optimization before. If bits is null, then it's in the size of a uint, I think, and then it's just gonna add them together. And otherwise, we have a function here that looks pretty interesting. Oh wow, big integer calculator, left bits and right bits. There's a big integer calculator, oh my god. Ref int, get reference, ooh. Okay, then we get into some unsafe code. That's crazy stuff with bit shifting. Yeah, okay, pretty much all manual work to add two big integers together. Feel free to look into it if you are interested in how it exactly works. But that's it for now, guys. I'm wondering whether you are actually using this BigInteger. As I've said before, I've never touched it in the last 12 years or so of professional C# development, and I can't think of a use case to use them myself in the daily work. Of course, I could replace all my integers with big integers, but why should I do that, right? Yeah, so if you have a use case for big integers, let me know. I'm very interested to know what use cases you could solve with this one. That's it for today, guys. Have a nice day. Bye-bye.